the first thing we're going to want to do is to bring in that mesh that we scanned and take a look at it here in Geomagic Design X. We can see that the coordinate system is in the scan system. So we're going to want to make our own coordinate system here. And so we're going to do that by grabbing similar triangles at the base and fitting a plane. And we want to make sure we don't have any constraints, as we'll just let the data guide this plane. And so that will become the base of our data. Now we're going to use this back surface to establish another plane. So here again, we're going to use a fitting plane without any constraints. So now we have two planes. To make our third plane, we're first going to go and extract the axis from the jack stand. This is balancing the object on there, so more or less it's pretty well aligned to gravity for the object. So this will be a good datum as well. And we will then use that axis to create another plane that we will then rotate 90 degrees to our back plane. And this will become our third plane, and we'll be working in this coordinate system throughout this project. As you can see here, we're not going to get this exactly where we want it, so we have a little bit more work to do yet before we define a center plane. And so what we're going to do is we're going to use that plane as a constraint, and we will select the data on the far side of the dish here. So here we're going to make the constraint. We'll do a best fit, but we'll make it to max, and we'll take a quick look and realize we need to do a min. So we'll change that to min, and we'll take another look, and there's the plane we want. So that plane is touching all of the outside data, but it is in the same direction as the plane we derived in the middle. So that's what we want to do. So we'll then do the same exercise on the other side of the tray and follow a very similar procedure. So we'll use our selection tool, and we'll come over here and select the data, do another fitting plane, enforce the direction to be the direction of the near center right there. And then we'll change it to min. Take a look, and we got it right. So it's just the same thing on the other side. And now we're going to create our perfectly centered plane, or very close, by grabbing both of those planes. And the software will know that we're doing an average plane, and there we go. So that is now our center plane. So we'll want to go ahead and define it that way. And, you know, we could perhaps delete some of these. I like to keep them just because I like to remember how the data was captured, and then I kind of rename stuff. So here I'm going to do base. And then some of the others I will rename as well. Like this one will be back. And then just to keep things tidy, I think we'll just go ahead and delete all those reference planes there, or hide them. So now we can see the planes that we're mostly going to be working with. We have 3 of them here: a center, a bottom, and a back. All right, to start on this part, we're going to do a mesh sketch. This is a really powerful feature in the software where it's able to section all of the data and give you some really great guidelines to semi-automatically create sections. And so that's what we're going to do here. And so we went ahead and used our base plane. And now we're going to take advantage of symmetry here. We have one side of this tray that's completely destroyed, and the other side is a lot better. So we're going to work with that side. So here we're simply going to go and use the auto sketch feature and pick the outside of that sectioned scan data. But we're only going to do it on one side because the other side's broken. So I really don't want to try to use that. It's going to be a little bit off. But to make the software happy, it needs a closed section, and so we will need to close that section. So looks like a misselect here, so I need to redo that outer contour one more time and make sure I hit OK. And then I will need to grab just a quick line just to connect the sections so that the software is happy. So there we go. Now we make this line picking these endpoints just to close off that sketch. And now we have a sketch here that we can extrude, and we'll just go ahead and pull it up past the part. We're going to do some cuts to clean this up. But before we do that, we're going to go ahead and work with the center cross section as well. So we'll go ahead and derive this as well. We want to use this to create a surface that we are going to use to cut the section we just made. So here we're going to use the silhouette feature, which allows us to grab kind of all of the high data within that volume box there. And so we're going to pick the side that is not damaged and use it, and it will give us this really great contour box. And we're really just after that one curve there. And so what we're going to do here is we want to make sure things work out well. So we're going to go ahead and use the resize tool. And all it does is do an extrapolation of that curve. And now we're going to do an extrusion, but the extrusion is going to need to be two-dimensional here, and then it will be happy. And we're just going to go ahead and use it. We'll just make it across the entire part here. It's just going to be a cleanup cut. So there we go. Now we'll go back down to that initial sketch that we did, and we will select it for a solid extrusion. And we're going to go ahead and just turn that back around. And we can actually make it go right up to the solid. And so that's the reason we'd kind of like to have that order of operations there, where we make the solid, or we make the surface cut on the top and then just have the solid extrude to it. It just saves us a command. It's a little bit cleaner that way. So this is where we are now. We have a big loaf, and we're going to need to continue to advance here. All right, so the section cut is going to clean up that extruded body. So the tool is the plane, the target is the body, and then we get to go pick what we want to keep. And when we did that extrusion, we didn't really pay attention to the fact there's a draft on this part. And so we can go back and fix that. Software lets us do that. So kind of playing on which side here is the draft, inward or outward. You can quickly tell when we turn on the deviation colors. You know, we're really looking for green, and the green band is actually quite narrow in this case. So just to exaggerate the situation, we show what it would be like if we completely made it an inward draft, and that's obviously wrong. So we're going to flip the sides, and now we're going to come back and slowly converge to where we get that green band about halfway through the part. That's really what we're after here. And like I said before, the green band is actually really narrow. I think a 0.5 millimeter is going to work out just fine for this part. So let's go ahead and make those extreme limits a little bit higher so that we have a better target for making the part green. So that makes it a little bit easier for us to have a pass-fail as we kind of toggle some of these draft angles. And so this looks to be optimal. All right, now we're going to use the shell command which is probably one of my favorites. It does so much work so quickly. So we're going to pick the faces that it's going to subtract, and then it's going to make everything to a given thickness. Now, I really like this tool because right here you can have it guess. It's going through a number of iterations to the mesh to figure out what the optimal thickness would be. And it gives us a little bit over 2.3. So we're just going to go with 2.3, and we're going to use that number for all of our thicknesses just to be consistent. But when we derive that, we used all of that data and let the computer and software do all the work of iterations to figure out that number. So now we're basically left with this tub feature, which is close, but it's not quite there. We need to go back in and add all of these nuances there along the top rim, and then also the features in the back, and then where it mounts to the refrigerator as well. So what we're going to do here is use this offset plane to do another mesh sketch, and we'll use the silhouette feature to capture everything in the volume. And we've got a curved top flange there, and there's a lot of geometry going on there. So what we want to do is just to take an orthogonal view, go ahead, capture all the data, take the high side of it, and then do an extrusion, and then use our surface cut that we made before. So this is the result of the outlying surface. So here again, we're going to use the auto sketch as it's a quick way of capturing all this geometry. And we're going to do a similar trick we did on the other side, where we only do about half of it, and then come in here and close the section. And we use the trim here to clean it up. Here we're going to use a surface offset. We're going to use our magic 2.3 millimeter number. And then we'll do a cut with this offset surface and apply it to our ridge body. And then we got to tell it which geometry we want to keep. And so we want to keep that top ridge there. So what we did here is we ended up just doing one giant body before we do the shell operation. And so that ended up making everything work out a lot better. And the magic shell, and look at that, all the geometry cleaned up and right where we want to be. And just doing a quick overlay here, just visually looking around. You're kind of looking for half gray, half blue or so. It means you're, kind of hitting the part scan pretty well. You could also turn on the deviation body, but I like to just do a binary comparison. All right, here we have these little features here on the lip of it, which is difficult to capture. So we're going to come in here and just do a scan for it, or a mesh sketch for it. And so yeah, there's this overhang feature here, which is kind of difficult to capture. So we'll use convert entities. So that's going to extract the intersection of that edge to the sketch plane. And we do a resize just to bring it over. All right, now we're going to use an offset with our magic 2.3 number. And so what we're looking here is just to kind of idealize this. It's looking like our offset isn't going to quite be realistic. Looks like it's a little more thick there than 2.3. It's about twice as thick. So we're looking at here with a line. There's not enough geometry there to get an idealized line. So here we're looking at trying to make a parallel line to that front part. And so when we gesture over there, you can see those two parallel lines in that green box show up. So we're able to get that line parallel to the front. And now we're going to go back and do an offset, and we're just going to have to just eyeball it. There's a little bit of fudge factor on this one right here. And so we'll kind of just eyeball there to make sure we have plenty of thickness. Now we're going to need to do a little trimming to clean things up. Looks like our sketch got a little bit out of sorts there, but we'll just kind of come in here and continue to push through. So we extrude that line. We've still got some lines to clean up here, it looks like. So we use the trim. And we'll trim that line. I think we may have had two lines there. So then we just do extrude or extend. So it should clean everything up. And I think we have a construction line here, so we're going to have a real line to close this section. And there we go. Okay, it let us out, so it's looking like we might have a 2D section here. And so now we're going to make an extrusion of this. And we're just going to pull it this way. Nice thing here is we can take advantage of the computer doing some heavy lifting here and let it figure out how to merge that into the body. Now notice how we have multiple solid objects as a result of that. That extrusion made itself its own body. And so we're going to need to do some Boolean operations and a merge to put that together again. Be a little more careful on selection, and there we go. Looking over in our tree, we can see that we only have one solid body now. And we've been able to capture that pretty well. All right, now let's go look at these nubs here on the back. And we are going to be 3D printing this part tray. So to have an injection molded design like this nub here probably is on the back is probably not 100% necessary. However, these little nubs do rest against the refrigerator as it has an interface joint there. It kind of allows it to pivot, and then it interacts with the refrigerator through these nubs. And so we need to have them there, or else the tray is going to overstress the joint at the top. And so it's important that we capture this. So we use a parallel plane approach again, where we grab the outside of that data, kind of like we did when we set up that center plane. And we just kind of visualize, make sure we got that. And that looks good. So now we got a plane there where we want this body to extrude to, this little nub feature. So we're going to come in here and do a solid extrusion. But we're going to realize we don't have a sketch. And so we're going to go do a mesh sketch. Use that plane, slide it forward. And try to capture that data. So we can make sure that we create something. Intuition might say, let's use the silhouette here. but it's looking like it's not helping us as much as we would think. So there we go. We have the pink, which was the resultant mesh sketch data. And I'm really just going to use a rectangle here. I don't think it's really necessary to do anything more than this. So if I grab that, it'll just fit a rectangle to all of that data, and I can just be done. All right, flip direction again. And then instead of trying to do some arbitrary distance, we can simply use the up to body feature here, and it'll magically do all of that for us. Now, there's a little bit of complexity going on over here, so we've got this little feature hanging off, so we're going to want to do a cleanup cut to fix any of that. And so that's not hard. We just take that bottom tool, pick the body, and then we got to make sure we pick all of that. And we didn't do it correct. That wasn't quite the result we were looking for. So maybe we'll do it again. This time we'll be more careful with our selections. And it looks like that is more of what we were after. So the interface to the refrigerator where it actually goes in and kind of forms a pivot point, looks like we lost that and we need to create it again. So we have a plane that grabs the extremity of all that data and it makes sure that it's normal to our center plane. And then we are going to go do the same technique where we're going to do an offsetted mesh sketch with the intent of just capturing that feature, so we don't really want other stuff. So we'll kind of use the cropping to make sure we don't pick up other artifacts. And it seems like a good idea to use the silhouette to make sure we're grabbing the extremity of that data, not just a certain cross-section. And we do want to go back. It looks like there's a damage here on a rib. I think we'll go ahead and keep that rib, even though it's probably an artifact of the injection molding process. I think it still would be okay to include it here. These drawings could be used for injection molding. And so here we're struggling a little bit. We cannot get the outside cross-section, came through really poorly. The silhouette feature, it seems like it's using a lot more data, and usually you use more data, you're going to end up with a better result. And that turns out to not be the case here, as that silhouette data just consistently would come in and make it very difficult to come up with a reasonable approximation of the scan here. So the solution was to go in and do a mesh sketch, but not use a silhouette. Just do a crisp section of it. And, go ahead and do cropping, or you're going to end up with more things to think about. So there you go. We got another nonsensical section there. So maybe we should be a little bit more thorough in the way we're doing our auto sketch. And so if we change some of these parameters, we get the result we actually want. We could have maybe done that with the silhouette feature as well, but nonetheless, we ended up with the section we were after there. So here we'll do an offset. We could maybe keep this one solid because we're doing a 3D print, but perhaps it's good to keep the design intent, and perhaps we'd want to go and make more of these in like a production run. That would be injection molded again. All right, so now we have that interfacing feature. We're going to go ahead and put this stiffener back in here. That looks like it got damaged. So we want to be able to get this stiffener to go all the way down to where it was before. And so the line tool will fit a line to the data that you select. And so we did that, and we're just going to extend it. And then here we're going to do a resize. We're going to have this kind of gracefully merge into the upper flange there. So now we'll do an offset to keep things all parallel. And we're going to need to do a little cleanup here. We need to make sure that extends down and intersects that lower island feature. And then we need to make sure we have a closed mesh. And I really don't care, as long as it is somewhere in that thickness, it's going to work out okay for us. So we'll do an extrusion again. We're going to use that trick of making it go intersect the body. And we're going to save ourselves a Boolean operation here by doing a merge. So looking at the part, this looks pretty good. And so looking around, we're considering just half. Let's kind of see how things are working out here. And here again, we kind of have our green band a little too loose. I think it's appropriate to be about a 0.5 millimeter on this one. It's just a refrigerator tray. This is not an aerospace turbine. And so I think that looks pretty good there. Except for it does look like there's quite a gap down here, so maybe we should do something about it. It looks like there's a fillet type feature. And so what I really like about the fillets in this software is that you go ahead and select your filleting contour, and then you can use the magic button here, which will automatically iterate and figure out the best fit. We saw this earlier with the shell feature when we were able to use a lot of data on multiple surfaces to come up with a best fit. So we did that again here. So we have a really good approximation for the radius. And we're going to do that trick one more time. We just need to go ahead and select all of this contour data again. All right, so we want to put a bunch of fillets here to match the inside fillet. So we're going to go ahead and let the software decide it wants about that size. And so we'll go ahead and extend that fillet around the part. But it looks like that operation destroyed our nubbin feature on the back. So here's the situation where hindsight is 2020. Perhaps we should have put those fillets on first and then created this feature. So we could do that, or we can simply go through here and try to rearrange these if they don't have dependencies, and maybe save ourselves a little bit of time if we don't confuse ourselves too much. So here we can grab the fillet feature and we can make it create earlier in the steps, the sequence. So we roll back the model to a previous time point. We put the fillet on. And then we come back, and what that does is it keeps that nub feature on the back while putting our fillet on the part. Problem is that cleanup cut isn't showing up, so we can reorder the cleanup cut. And we had trouble reordering that cleanup cut. So what we'll do is just delete it out and we'll do it again. And we didn't quite get the result we were after there. So we suspect that that nub feature somehow is causing this problem. So we'll go ahead and redefine that box and just make sure that it completely clears that cutting plane. When we come back and do the cut, and we're careful to pick the right features, we end up with the result we want. Except for we lost this interfacing feature over here. So what happened on that cut is we needed to select this body as well, or else we're going to lose it. So we can go back and redefine that. All right, so now we have a All right, now we look at how well we did on this side of the tray. Most is in the green, about half it's in the blue, and then half maybe in the red. So that's about where we want to be here. All right, so here we go. This is the final product. Now we have a parametric solid of the refrigerator tray.